Hello everyone. I welcome you all in the next lecture of 12th class NCERT Mathematics. In this video lecture we will discuss question number 31, question number 32, 33 and question number 34 of exercise 5.1 of chapter 5. You can see here. So as we discussed already, question number 1 to 30, you can see that the complete exercise 5.1 is based on the continuity and the definition of continuity. So before that, what we applied, definition of continuity and some useful terms we applied there. Okay, like in a previous question, question number 30, what we discussed that pair of the concept is definition of continuity, LHL, RHL, and the function value f of a if the function is continuous at a, and we applied that pair of linear equation, how to solve pair of linear equation by cancellation method or by substitution method. Okay, so here some other different things are coming. What the different things are? Here you can observe, here show that the function f of x equal to cos of x square is continuous. F of x equal to mod of cos x is continuous. And here they are saying examine the sin, examine that mod sin x continuity. Okay. And in the 34 question, they are saying find all the point where the function is discontinuous. The function is mod of, this is your minus, mod of x minus mod of x plus 1. So in all those questions, we need to discuss the continuity of the function. Okay, first thing you can observe here. The second thing which what we need to observe here, that the function are in composition of other function or in addition or subtraction they are defining. Okay, so here you can see that f of x is basically solution for this question. Just I give that f of x equal to the cos of x square, we have cos of x square we have, and here you can see that one is outer function, other one is inner function. So what is your outer function here? You can write outer function is your cos x. Okay, and your inner function is x square. Okay, now why we are including this, why we are in adopting these new term, that is outer function, inner function here, because we are proving the continuity in a different manner. Before that, from question number 1 to 30, what we did, we simply apply the definition LHL equal to RHL equal to the function value. Okay, and check that are they equal. If all three terms are equal, LHL, RHL and the function value at particular a, if we are checking, then the function is continuous. But here we can go by that term also, but it is quite lengthy. Okay, so we can instead of that, we can using the algebra of continuity or composition of continuity of the function, as we already have a theorem in NCERT, so we can use. Okay, so here we have f of x. Let us assume that let our g of x, that is our outer function, I assume that is cos of x, I assume. Okay, and here your h of x is x square we have. Okay, so first of all we need to find what is the domain of f, because on the domain we need to discuss now. So the domain of f is, first of all we need to find the domain of g. Domain of g, d of g I represented, d of g is complete R and d of h is also complete R. Why so? Because you already know the what is your, how we can do the graph of cos x. Cos x is like that, the domain of cos x is complete R. Domain of cos x is complete R, and the range is in between 1 and minus 1. Suppose it is 1, it is minus 1, it is 1. Okay, and other one function is our x square. X square domain is also complete R, and you can see the graph is like that. Okay, this is your graph. Okay, so domain for that is complete R. Its range is close minus 1 to 1. Okay, and its range is complete R positive union 0 we have. Okay, these are the range of these functions. Now observe that, observe that g of x and h of x both are continuous on R. If they are continuous on R, then if they're continuous on R, then their composition also continuous. So observe that Gx and Hx both are continuous, hence there, or you can write a language also. Gx and Hx both are continuous as one is as Gx is trigonometric function and other is polynomial. Other is polynomial. Okay, and we know that they are continuous in their respective domain. Also, we can observe by the graphs of both that we can draw the graph of cos x and x square on complete R without lifting our pen. Okay. Now, as both are continuous, so it implies that their composition, their composition function f of x equals to, what is our composition given here? G of hx is given here. G of h of x. Okay. G of h of x. Here I need to write one line that d of f is also R completely. Okay, as the d of g and d of h is complete R. Okay. So their composition function fx equal to the g of h of x. Now their composition function f of x is also continuous on R. So implies that f of x equals to cos of x square continuous on R. Now, one more thing you can observe here, that additionally we can say that h of g of x, additionally h of g of x. What is our h of g of x? H of g of x is our cos of x whole square. Okay. How we can find? See how we can find. I will write here h of g of x, and here you have h of, what is our g of x? Cos of x. And what is it? This is your x square, so here we get cos of x whole square. Okay, this is also continuous, also continuous on R. Okay, so like that we can proceed, and we can show that it is quite easier as compared to in writing, because that is also easier, LHL equal to RHL equal to the function value, but it's that one is a quite lengthy, so it is quite short. Here you can observe that what I said here, that the domain of this function is complete R, as the domain of G and H is R. You can also observe that Actually, that is not a correct reason. The domain of f is complete R. See, the range of x square is positive real number, and we observe that for every positive number the cos x is defined. Okay, that's why our domain of f is complete R, because for each input, if I am giving input here from the complete set R, what output we are getting from this output? We are getting R positive union 0, we are getting output, and at that output the function cos x is also defined. Cos of that R positive union 0 is also defined. So for each element from the R we get output from this one, hence the function domain is complete R. There is no problem. Understood? That's why the domain of this function is complete R. Okay, and hence we have the same method, that because gx and hx both are continuous, hence their composition also continuous. Now we are moving toward next question, that is 32. What they are saying, f of x we have cos mod of cos x, and here you can see again we can assume, let what is our g of x here? Outer function is mod of x function, and your inner function is here cos of x, here inner function is cos of x we have. Now see, the mod x graph is how we can draw the mod x graph. You can observe here the mod x graph is like that. Okay, and your cos x graph is as we discussed here already, but we can draw, no problem for this question also. Like that we can draw the graph of mod x. Okay, yeah, this is your 1 and this foundation is your -1. Here it touch. Okay, here it touches, like that it touch completely, it will touch. Wait, I will draw again once again. Wait, yeah, it will be like that. Yeah, like that we have a cos x graph. Okay, it is continuous. Now clearly domain of f of x is complete R, because here also the range of our what a function mod x function is also 0 to infinity, close 0 to infinity, and the for this one is close -1 to 1. Okay, you can observe that here that mod of cos x is given, and cos x range is -1 to 1. Okay, so first of all what we did, first of all we will give input to this x, the x which is present here na? From the complete R we will give input. Okay, and this cos x output is in between, that this cos x output is in between -1 to 1, and we need, after that the output which we came, we need to apply mode on that. Okay, we need to apply mode on that, and mode is defined on complete R, so we are getting output corresponding to all these elements also. It means that for each element from the set of real number we get output corresponding to fx or not. It means that domain of fx is complete R, like that we can tell. Now we can observe that gx and hx both are continuous, on R, both are continuous on R, because one is a mod function, mod of x function, other one is a cos of x function. Okay, as gx is modulus of x function and h of x is cosine of x function. Okay, so it implies that their composition also continuous. It implies that f equals to g of h f of x equal to g of h of x also continuous on R. Okay, continuous on R. It implies that f of x equals to mod of cos x continuous on R. And graph also we can observe for this one. The graph will be this one, then this one, then this one. Like that we can draw the graph. Okay, see, there is no breakage. We can draw the graph of cos x without lifting our pen. Okay, see how we can draw. Yeah, here, then here, then here, then here, then here. Okay, and after that also. So without lifting a pen we can draw the graph of mod of cos x and the function is continuous on R. Or we can say, we need to write actually one line that f is g is continuous, h is continuous, and their composition also continuous. We need to write that line here. Okay, okay, and hence the function is continuous on complete R. Okay, now we are moving toward the sign of mod x. See, here mod cos x is given, here sign of mod x is given. Now actually they are both of opposite function. Okay, so here we have f of x is, this is your f of x is sine of mod x function. Okay, if you have sine of mod x, now outer function I assume g of x is sine of x. Okay, and your h of x is mod of x. Your h of x is mod of x we have. Okay, now how we can draw the graph of sine of x? Sine of x graph will start from 0. Wait, I'll draw the graph properly. Here you can observe, like that we have, like that we have, like that we have, and it goes on. And here also, like that. Okay, and what is our mode of x graph? Mode of x graph recently I drawn, but I will draw for this question also. Like that we have mode of x graph. Okay, so both domain for both of them, wait, I will write here, d of g is complete R, d of h is also complete R. Range for above function is -1 to 1 and range of this function is 0 to infinity. Okay, as you can observe here that this thing is given. Okay, so if we are giving to find the domain of f, what we need to do, see, if we are giving input from a set of real number to this x, then mode we need to apply on that, and which gives output as close 0 to infinity. And close 0 to infinity is also from the real number, na? So every real number sign is defined, because you observe that here you can observe the sign is defined on complete R. So it is defined on also 0 to infinity, hence it will give definitely output corresponding to every real number. It implies that the domain of this function is complete R you have. Okay, I hope you understood why the domain of this function is complete R. Now you can observe that as g of x, same thing we need to write, g of x and h of x both are continuous, both are continuous on R, then their composition, g of h of x is also continuous on R. And what is its composition? As g of x is sine of x and h of x is mod of x, so our f of x is equal to the sine of g of h of x, that is sine of mod of x is also continuous on R. So I hope you understood this thing, how we prove this thing. Okay, by simply we are applying the we are applying the composition of continuous function. Okay, in all the three questions we did the same thing. Now find all the points where the find all the points of discontinuity of f defined by f of x equal to this one. It means we need to find the points of discontinuity. Okay, here you can observe that your this is a solution. Your f of x is here, mod of x minus mod of x plus 1 you have. Okay, so your fx is written as in the format of g of x minus h of x. Okay, what is your g of x? Our g of x is mod of x, and our h of x, our h of x is mod of x plus 1 we have. As g of x and h of x both for both domain is complete R. So as the domain of G is complete R, domain of G is complete R, domain of H is also complete R. So the domain of f, how we can find, as this algebra is given here. So d of f intersection d of, sorry, wait, d of G intersection d of H, and what it will be? Complete R. So the domain of this function is complete R. First of all, you need to find this thing. Okay, now discuss the continuity. As now we can draw the graph of mod x. How we can draw graph of mod x? Mod x graph is this one. Okay, and what is the graph of our, what is the graph of our mod of x plus 1? Mod of x plus 1 is this one graph, like that we can draw. This is our minus 1 comma 0 point, and this is our 0 comma 0 point. Like that we can draw the graph. See, both the graph we can draw on complete, both the graph we can draw on complete R. Okay, so here, and without lifting up pen we can draw the graph. Okay, and also we can observe that the modulus of x is continuous and mod of x plus 1 is also continuous, as we can draw the graph of the function without lifting our pen, or we can use the definition also. So as our g of x and h of x both are continuous on R, implies that by using algebra of continuity of the function, by algebra of the continuity of the function, we have, by the algebra of the continuity of the function, we have f of x equals to g of x minus h of x also continuous on R. Okay, so it implies that clearly f of x equals to mod of x minus mod of x plus 1 is continuous on R. Okay, and if this complete function is continuous on R, then how many points of discontinuity have? It implies fx has no point of discontinuity, no point, or fx has 0 point of discontinuity, 0 points of discontinuity. As f of x is nowhere discontinuous. Okay, so I hope you understood this question also. Here also we are using algebra. Here we are using algebra of continuity. Okay, in alone question number 34. Except the 34, in all the three questions 31, 32, 33, we discussed that algebra composition of function. One function we have f of x equal to the cos of x square. So here we are using composition of function. Here we are in second function, second question also we are using composition of function. In third question also composition of function. Okay. So like that we can use composition of function, because theorem is also in NCERT that if we have a function fx, another function g of x we have, and function f and g both are continuous in their domain, hence their composition also continuous, the domain which we define. Obviously the domain of the composition is subset of the domain of f and as well as of g. That's why. So I hope you understood this question. Okay, if you have any doubt then you can do comments. Okay. Thank you for watching.